Hello everyone, I'm happy to welcome you back to the Retro Programmation channel. Today, we're going to do a little tutorial on how to manage the score in video games on the Commodore 64. So, I won't talk much, I'll mostly write code. If you have any questions, feel free to ask them in the comments. And right away, a small basic program to see if everything is working well with the compiler. And we'll get started. So the first thing to do is initialize the score. And so I'll immediately declare some variables. And initialize these variables. With a score of 0. And a high score of 1000. So, the memory organization of the score is score, score plus 1, score plus 2. So these are the three memory locations. And they are stored in reverse order compared to the display. That is, score contains the units and tens, score plus 1 contains the hundreds and thousands, and score plus 2 contains the 10,000s and 100,000s. And so here is how to represent the score 1 2 3 4 5 6. And the principle is the same for the high score. Next, we're going to display this score. And so I create a function display_score. There. So here I increment y. I need to decrement it to be in the correct order. So, a small issue, I only have 4 digits whereas I should have 6. There, I have 6. However, they aren't the right characters. Look here, I put 12. 12 plus 48, that gives a lower character. If I put zeros, I have 6 zeros. And the problem is that I forgot the dollar. When I put a dollar, I get the correct values displayed. So that was for the score display. We do the same thing for the HiScore. There's no secret, it's a copy, just the position changes. There. And so if we display it. Ah, I'm missing some digits. Yes, I forgot. HiScore here. Okay, I display the score. Now, if I correctly take the HiScore value, it should display 32s instead of 12s. There, it's good. So let's set the score back to 0 and the HiScore to 50-50. And there we go. Next, now that we've displayed the score, we're going to manage the score. So we need to be able to add points and subtract points. Let's start by adding points. So a function that will add 10 points to my score. Without forgetting to propagate the addition to score +1 and score +2. A small loop. So, we must not forget to display the score and there. It works, or almost. We see there are strange characters and that's completely normal because the secret now is to use the processor's decimal mode. We'll activate it with SED. And at the end, we deactivate it with CLD, set decimal, clear decimal. And you see, we have a system that correctly adds 10 points. So it's going very, very fast. If I add 3 points at a time, it will go a bit slower. But the principle is there. I'll slow it down. There we go. So, it adds 3 points at a time, except it doesn't do it for just one frame. That's why you see the numbers going up very fast. It does it multiple times per frame. I'll put my 10-point addition back and I'll create a second function within this function. To add the number of points we pass as a parameter. It's here that we'll have the add_10_points function and the add_a_points function, the value we pass as a parameter. And there, we can see that the units are either zeros or fives. So that was for adding points. We'll do exactly the same thing for subtraction using remove_10_points and remove_a_points. We switch to decimal mode. Since it's a subtraction, we don't forget to set the carry flag. And we'll transform the generated code by putting the value to subtract in the SBC. I load the score, I subtract the value that was passed as a parameter and all the rest is the same, except that we subtract instead of adding. And there, it's done. So if here I add 10 points and below I subtract. I'll set it to 5 points. And I'll subtract 1 point. So we're dealing with multiples of 4. However, we end up with negative values. So, I must have forgotten something. Yes. That's good. That's good. So, why do I have -32? I'll just do the addition to see if the addition gives me 5. And when I subtract 1, I end up with -32. What sorcery is this? Okay, it's here that I needed to put the SEC just before the subtraction, of course. And so no, that's still not it. Ah, the hashtag is missing. My mistake. Actually, it fetched the value that was in the memory. There, that's much better. Good, Now it correctly subtracts the value I passed as a parameter and no longer the value located in the memory address passed as a parameter. That is, here the memory $01 which by default on the Commodore is 37, and so I rightly had minus 32 because I had added 5 and then subtracted 37. So now, we're going to manage the high score. That is, if the score ever exceeds the high score, then the high score becomes the value of the score. So, that's a simple comparison. We take the score, we compare it to the high score, and if it's greater, we update it. So we start, of course, with the highest value. If the score is less than the high score, it's not beaten. If it's greater, then it's beaten. Otherwise, that means it's equal. And so if it's equal, we'll need to compare the other values. That is score plus 1 and then score plus 0. If the score is beaten, so it's right after. So I can remove this here. If the score is beaten, then we update the high score. And if it's not beaten, we do nothing, we exit. And there's the high score check. We'll also display it only if it's been beaten. There's no point displaying it if it hasn't been beaten. And so we'll see if that works. It's perfect. So that's the basics of score management on 8-bit computers, and here in particular with code for the Commodore 64. So what we'll do now is remove the unnecessary zeros. And so we'll use a temporary memory location TMP. I'm going to rewrite this whole part. Since it's in there 2 times. Actually 4 times, since we also use it in display_HiScore. And we'll be able in this part precisely to replace the unnecessary zeros with spaces. I check my temporary variable which I set to 0. If it's not equal to 0, it means there has already been a digit. And so we'll switch to the system that returns a digit. This system that returns a digit takes the value, adds $48, $30 and returns the digit. If TMP is equal to 0, it means we haven't yet had any digits greater than 0 to display. And so we'll check if our digit is a 0 or not. If it's equal to a 0, we return a space. If it's different from 0, we'll return a digit. So here, I return the space character 32. And so here, in this case, it's the first number greater than 0. So, I increment my TMP, meaning that TMP on the next pass will no longer be equal to 0 but will be equal to 1. And therefore, I won't go through this little bit of code anymore. Is underscore number, I move it here. This, I replace with a JSR set underscore number underscore space. Twice of course. And normally if I execute, it doesn't work. So what did I forget? The PLA. Okay, I do a PLA twice, so obviously I have a problem. So, we'll see here a little trick, which is to use a useless function to jump over our PLA. We'll say, just after incrementing TMP, we tell it to do a bit on a 2-byte parameter, which is actually the PLA. To do an override, i.e. to skip over the PLA that comes just after. And so there, it should work. There. So you see, I no longer have the zeros that come before my digits. We'll do the same thing for the HiScore. We have a little issue. Yes, but it's completely normal that we have this little issue because I forgot to initialize TMP, which we use in the function. And so I'll copy my STX TMP to put it here as well. And everything should work fine now. There. So we'll set it back to normal speed. And we'll add a parameter, the space character. So since I'm using the standard Commodore character set, it's $20. And similarly, the digits start at 48 up to 57. So the 0 is 48, i.e. $30. Which means that if you change by using your own character set where the digits aren't in the same place, you only need to modify just these two labels, these two parameters. In your score manager, just like the position of the score which I put at $0400, 1024, and the high score which I put at $0400 plus 34 can be all the way to the right of my screen. And that's all for today. I hope you enjoyed the video. In the next one, which will also be about the score, I suggest we display this score no longer with characters but with sprites. The advantage of using sprites to display the score is that we can move the sprite around the screen, make it move, but we can also display it outside of our normal screen area, meaning above the zone normally displayable by characters. I hope you enjoyed this video. If so, please give it a thumbs up. Don't hesitate to ask your questions and leave your comments. I answer everyone. And until next time, I wish you a beautiful and pleasant day. Take care of yourselves.